Greetings to Prof and those who are watching this. I am Chia Zheng Xun from Group 6 who will be presenting Milestone 4 for our group project. Our objective is to diagnose and overcome overfitting in our two models, logistic regression (LR) and random forest (RF). We started with a trend test gap analysis. The results showed that the RF has an F1 score gap of 0.411. This is clearly overfitting. LR had a accuracy gap of 0.0054, which can actually be considered okay, but it has a low F1 score of 0.482, which indicate class imbalance but not overfitting. Next, we use the learning curve to be sure about this. For LR, training and CV, cross-validation F1 scores, converge closely, which is a sign of high bias. For RF, training F1 scores stayed pin at 1.0, whereas CV F1 scores plotted right below it, and actually the gap never closes. This actually helps us in confirming the severe overfitting. To overcome this, we apply three techniques. First, regularization for LR. We search both L1 and L2 penalties across 6 values of C using 5 full-grid search CV. The best one is L1 with C equals 10, was selected with a CV F1 score of 0.5164, which reduced the F1 gap to 0.0332. Second, pre-pruning for RF. Pre-pruning restricts how deep each decision tree can grow during training to prevent memorization. From none at the beginning, now we tune max depth and minimal samples per leaf through grid search CV across 48 combinations. The best configuration identified is the one with max depth 20, which achieved a CV F1 score of 0.6265 and managed to reduce the F1 score gap to 0.3916. Third, we address the class imbalance in the dataset. Applying class weight equal to balance, we weight the loss function to penalize minority class list classification more heavily. These are some of the noted gains from these techniques. One of the notable gain is actually the RF F1 gap reduced by 11.5%, which is to 0.3639. Therefore, our best model is random forest optimized plus balance, achieving a test F1 score of 0.6266 and ROC AUC of 0.9162. Thank you.